today's tutorial, so magfo-focus tayo sa ORGCHEM, specifically nuclear magnetic resonance. So let's now go to the next slide. Okay. So to give you an overview, we'll have the introduction. Siyempre, we should know the theory and principles behind NMR. And then we'll go to the main topic, NMR spectroscopy, and then the main topic, which is the proton NMR. And it has three components, chemical shift, integration, and coupling. And syempre, sample problems. Paano natin sila aatakihin sa exam? Okay? So let's now go to the intro, So what's NMR? So basahin ko na sa screen, it characterizes organic molecules by identifying CH frameworks. So when you say CH frameworks, yan yung carbon-hydrogen frameworks natin sa ating organic molecules or our hydrocarbons. So ano ba ang mga sikat na organic molecules na lagi natin naririnig? Diba? Yung chons, carbon, hydrogen, oxygen, nitrogen, chons. Tapos minsan, PF, phosphorus and fluorine. So yan. Lagi silang nakikita sa hydrocarbons. So, si NMR, it explores magnetic properties sa mga atomic nuclei. Bakit? So, ito kasing mga atomic nuclei natin, they can, when they spin on their axis, they can form, they can induce magnetic fields. So later, ipapakita rin natin yun. Bakit ganun po? So different atoms, or nucleus, can produce or induce different types of magnetic fields, hence different types of signals. So we can determine the properties, either physical or chemical, of molecules they are incorporated. So paano po ba yun nangyayari? Why do we use NMR, So we can take account the physics behind nuclear spins of these atomic nuclei when subjected to an external magnetic field. So so paano ba nangyayari yung spin in nuclear terms? So syempre, we had to review quantum numbers. So, di ba? That's how we name the electrons or the positions of the things that are spinning in the quantum realm. So ang main focus natin diyan, syempre, sa spins nila, which is this one, quantum number. Okay? So I think everyone naman here is familiar with quantum numbers. So hopefully, hindi ko na siya i-discuss. We have to focus on the spin. Yan. Okay? So paano po nangyayari yung spin, So sige, before we discuss that, ano ba itong mga quantum number? It says here, principal, it's the distance from the electrons to the nucleus. So ito yung principal quantum number. So kaya nakalagay dito, it's n equal 1 kasi it's 1 radii, for example, away from your nucleus. So ano bang components ng nucleus, guys? Anong components ng nucleus? Kaya sa mga face-to-face, can you answer? So, di ba, we have, mayroon nata nagchat-chat. Sorry, hindi ko makita. Ayan, proton and neutron. Okay, very good. So, for example, this is your atom, Let's say you have yung nucleus mo, which contains your protons and neutrons. Tapos, umiikot-ikot dyan ng iyong electrons. So, ang nucleus na tinatawag ito, nasa gitna. This one, yung red. Yeah. Okay? So, okay tayo dyan. So, next naman, azimuthal or your angular momentum, that's the shape of your orbital. So, it's denoted by L. And your operation is 0, 1, 2, 3 until n-1. So review nyo na lang yan kasi hindi natin yan focus for today. I'm just giving you an intro para di kayo malilito kung ano ba yung spin-spin na nangyayari. Ano ba yung relevance ng spin. Next, let's go to the magnetic side. So that's the orientation. It's either in the x-axis, y-axis, or z-axis. And its values are from negative L to positive L. Ang pinaka-center niya ay 0. Okay? So, and then, yung spin, it's either upfield, field, or downfield. Okay? So, later discuss natin, ano pa upfield, ano pa yung downfield? No? It's either positive 1/2 or negative 1/2. So, itong numbers lang naman na to, no? These are just orientations in the orientations of the rotation of the speed. Anong importance po niyan, kuya? O, mamaya discuss natin. Bakit siya important? Bakit spins are important? Sorry, hindi ko maklik. So ito, spin quantum number is related to the atomic and mass number of the nucleus. Sige nga, anong difference ng atomic sa mass number? It's the number of, pag atomic number, it's the number of protons. Okay, correct na. Correct. May nagsagot po sa ating direct message. Pwede bang makita po, pwede po bang mag-message sa everyone in the meeting? Ay, hi Seth, andito si Seth. Okay. And if you can chat sa everyone in the meeting, please do. So sabi ni Francis, hello Francis. So atomic number is the number of protons. Atomic mass is the number of protons plus neutrons. Diba? So in here, no, as you can see, half integer is the spin number. So the atomic mass of your prosium hydrogen is 1/2. And its mass number is, the atomic mass is odd, the atomic number is odd. So it spins. Umiikot po ito. Okay? So, may question sa baba. Which of the following can spin? Are you familiar? So, paano ba nag-i-spin ng molecules? So, to give you a background, sige, medyo complicated yan. Sabi dito, no, elements with either odd mass number or odd atomic numbers or both have the property of nuclear spin. So, yung mga half integer and integer, no, they are NMR active kasi yun yung focus natin. So, ibig sabihin, may signal silang ma-produce kapag pumunta sila sa NMR, pag sinubject sila sa NMR. Okay? So, pag even-even, hindi sila pwede, no? That's why we have here carbon 12, no, versus carbon 13. So, anong difference ng carbon 12 sa carbon 13? It has to do with their mass number. So, si carbon 13, mass number niya 13. Pero si carbon 12, 12. Okay? Ayun. So, basta odd ang kanyang atomic mass, it can spin. Or odd ang kanyang atomic number, it can spin. No? Kapag odd rin ang kanyang atomic mass and atomic number, no, it can spin, pero hindi pwede pares na even. Ayan. Carbon 12, no, hindi iikot yan when subjected, no, to a certain magnetic field. Ayan. Okay. Ayun. So, given, no, sinasabi natin, ano po itong mga spin-spin na to, no? Ano ba anatomy ng atom? Binigay ko na kanina, no? So, you have your nucleus, no? And, so, if this is your nucleus, no, meron tayong surrounding electrons dyan. So, alam niyo naman, di ba, electron cloud model? So, it's electron cloud na ang nag-occupy sa labas ng ating atom. Hindi na siya planetary, hindi na siya pudding. So, any position in the electron cloud, may probability yun na tinatawag. Yun yung electron cloud model. So, sige, tingnan natin. So, your nuclei can act as a magnet. So, for example, this is your nucleus, no? And it spins. So, for example, this is your axis. This is your nucleus. So, iikot yan na ganun. So, as it rotates, no? As it rotates, ito yung rotation. Kasi ito yung direction of rotation, no? It induces a magnetic lines of force, a magnetic field. So it acts as a magnet. Kasi di ba ang ating magnets has what? North and south poles. Pag may north and south pole, pag umikot yan, expected na meron kang magnetic field na may induce. Diba? Okay, so based sa ating may questions kasi dito. So what is the structure of hydrogen nucleus? One hydrogen, prosium nucleus. So later we'll discuss that. Kasi what are the numeric spin energy states of H or C? So sige, yung pangalawa kayang masagot yan. So what are the numeric spin energy states of H and C? Kasi pinakita ko na kanina sa previous slide. Sige, 10 minutes na tayo. Okay. So, upfield na naman and downfield lang naman, guys. Sorry. Ayan. So, even odd, it's either half integer, meaning 1/2. Integer, it's either 1, 2, etc. No? Pero in this case, kay, as you can see the screen, ito, no? Si prosium may meron siyang 1/2 spin. So, pwedeng positive, pwedeng negative, 1/2. Pwedeng positive, 1/2. Si carbon 13 rin, pwedeng positive, 1/2, negative, 1/2. Si hydrogen, +1, -1. Si carbon 12, wala. Okay? So, it's self-explanatory naman, no? The axis of spin and of the magnetic moment. Ayan, no? As it rotates, no? It produces a magnetic field. So, naintindihan naman po ito. So, ano po bang relation ng spin? Ano pong relation ng spin, kuya? Dun sa... sorry. Dun sa ini-induce niya na magnetic field. So, ito yun, no? So, a spinning proton, sorry, hindi ko natanggal yung mga annotation. A spinning proton can create a magnetic field. So, yan yung, ito, yung kanina nating nakita. So, as it rotates, no, it creates an induced magnetic field. Pero, with no external magnetic field, so, denoted by B0, magnetic field, yan yung magnetic field natin, the nuclear magnets are randomly oriented. So in space, no, in quantum space, may sarili-sariling axis yan, may sarili-sariling orientation yan, depende kung saan sila oriented. So, pero if there's a presence of a magnetic field in this corner, your nuclear magnets are oriented with or against your external magnetic field. Can you see my annotation? Kita ba annotation? So this is your magnetic field direction, no? And as you can see, no, different orientation nito. The second nuclei, pababa siya. The third, pataas naman siya. So ano pong importance niyan, no? So since this is a tutorial, no, siyempre padadaliin natin anong importance niya. So ito yung kanina, no, as you can see, if you can, ito yung nangyayari when it spins, no, yan yung mga magnetic field lines. And then, ayan ang sinatawag natin na alpha or beta states. So, for example, no, if your, sorry, nandito kasi yung mukha ako sa, if your applied magnetic field is, if your nucleus is in line with the applied magnetic field, no, in direction of the magnetic field, it's on the alpha spin state. So, tandaan nyo lang alpha. Pag alpha, along. No? Pero if it's against, no? If it's against, so this is yung against mo. If it's against the applied direction of the applied magnetic field, it's the beta spin. So pag alpha, it's positive 1/2. Pag beta, it's negative 1/2. Hence the importance of your quantum numbers. Naintindihan po ba yung concept of quantum numbers? Bakit siya important dito? Sa ating mga face-to-face learners. Gets ba? Pag may hindi gets, may tanong. How about sa ating online learners? Online learners. Guys, kung hindi gets magtanong po. Okay, gets naman daw. Okay. Sige. Ano, so it spins, randomly spinning siya. Pero pag nag-apply ka ng magnetic field external, they will be oriented, no? Either along the magnetic field or against the magnetic field. So syempre, may difference in energies. Etong mga ito, let's say this is A, no? It has a different energy with B. So by default, lahat naka-alpha kapag ano. Sorry, bakit A? So, sorry. Ay, nako. Sorry, sanay ako sa Apple Pencil na ano. A, o B. Let's say A, B. So, I'll discuss later, no? Ito ay nandito, no? That's A. Ito, saan siya? Why is it against the magnetic field? So, when you're against something, anong ibig sabihin? Malakas ka, di ba? So, if you compare the energies of your alpha compared to beta, ano ang mas malaki ang energy? Is it the alpha or the beta? Kasi against siya sa magnetic field. Pag may against ka sa magnetic field, gusto mong against ako dyan. So, anong gagawin ko? Tataasan ko yung energy. That's why your beta states are always high in energy. I'll discuss ano tong change in energy. Pero, tandaan nyo, laging mataas si beta kay alpha. Bakit po? Paano po nangyari yon? Okay? Paano nangyari yon? Eh, di punta tayo sa ayong mag-next. Ayan. So, ayan. So, ayan yung slide natin. Oh my God, 20 minutes na tayo. Ayan yung slide natin for the energy change. So, as you can see, no? And this is your direction of your magnetic field. And you have two rotations, either the positive or the negative. And as you can see, there's a difference in energies. Your alpha spin state is along your external magnetic field, and it has the lowest or the lower energy state than your beta spin state. Kasi along lang siya eh, susunod ka lang eh. So bakit? Passive lang ako. Ganun, punta lang ako with the magnetic field. Pero kung gusto ko against ako, I wanna tussle. Ganon, you go to the against, no? Beta state. That's why it's higher in energy. Okay? So, if we want your alpha spin state to be in the beta spin state, anong gagawin natin sa alpha spin state na nucleus natin? Anong idadagdag natin? Pagkain? Parang wala na ako nakikitang responses sa online participants. So based from this, no, anong nagdagdag? Anong nadagdag sa kanya? Sa beta spin state. Lagi ko na sinasabi kanina pa. So iteration na lang. Ano? Oh, correct. Correct, energy. Di ba nga? Oh, the change in energy will make your alpha, ayan, correct. Yan. From alpha spin to beta spin state. So pwede mong i-convert, pwede mong baguhin yung spin state ng alpha to beta and vice versa. Okay? Discuss natin later. Paano? Paano mo man? Ito naman. How would you change the spin state of beta spin to alpha? Ano naman, may dadagdag ka ba? May tatanggalin ka? Magdadagdag ka pa na energy? Is that correct? Anong gagawin? Correct. Magtatanggal tayo ng energy. Bababa siya ng energy, the same level as the initial energy, which is 0 or lower, for it from beta to flip into alpha. So kuya, ano bang importance ng change in energy state? Sige, tingnan muna natin. Ano po bang importance niya? Ayan. So as you can see, no, yung magnetic field strength natin dito ay 0. Okay? So as we increase the magnetic field strength, no, there's a change in energy. So, minsan, gusto natin na si device natin maliit lang. Yung ibang nucleus gusto nila mas malaki na magnetic field strength. So, yung iba, no, before they go from the alpha spin state to the beta spin state, they need a greater energy change. Pero ito, no, andit lang ng energy change niya, no, 1.41 Tesla lang. From alpha to beta. Maliit lang. So, compare mo dito. O, let's say this is atom A. O, this is atom B. Sige. Parehas silang naka-alpha state. So, kung tatanungin, sino ang mas kailangan ng energy to go from alpha to beta? Is it A or B? B. Oh, sinabi ko na. Correct, B. So, ito. So as you can see naman dito, no, with no field, common lang sila na area dito, no. So pero as you increase the energy, no, ito wala. Ayun. It's either you go to the +1 or -1 against the field. Sorry na wala po aking. Pero kuya, hindi mo pa na-explain yung hindi mo pa na-explain yung bakit kailangan ko siya i-flip. Bakit kailangan ko siya i-flip? Bakit kailangan niya from alpha to beta? Ano bang paki natin dyan sa NMR? Ayan, so ito ang ating, sige, just it's an explanation ulit, no? A diagram. So lower energy state, no? Alpha siya, pataas. Pero, absorbing RF radiation causes the nucleus to spin flip. So ano tong RF? Ito ang radio waves, no? So yung radiation from your radio waves, no, radio frequency, causes the nucleus to spin flip. So from alpha, mag-split siya into to beta. No? This is a higher energy state. This is a lower energy state. No? May question tayo dito. Oh, nasagot na yan, no? What RF is needed for the nucleus to flip or resonate? So later masasagot natin yan kasi hindi po masyadong clear. Okay? So, sige. Yeah, okay. So luckily, no, different nuclei possesses different absorbance to radio waves. So ito yun. So ito yung sinasabi ko kanina. So itong nuclei na to, different siya dito. No? So it needs a greater energy for it to flip. Unlike dito, konti lang. So yan yung ina-account natin sa NMR. Yan yung kailangan natin for the signals in NMR. So I think you are familiar with Organic Chem Tutor. Galing to sa kanyang video. Pero for the sake of our discussion, ganito lang naman ang nangyayari. So flipping, so this one, no, from your alpha, it will flip into beta, no. When your nucleus flips, it's called resonance. So may two terms kasi ang resonance, no? In organic chemistry, resonance is the stable structure, no, of your when it comes to your electron cloud. So yun yung ibang resonance. Pero in here, no, when it says resonance, no, it resonates with the frequency given. That's why it's term resonance. Pero basta ang mahalaga lang naman dito dahil tutorial to, resonance, nag-flip na siya from alpha to beta. So this is full of energy. Marami siyang energy eh. What if bumaba na siya from beta to alpha? Ito, this direction. So we are assuming ang direction pala ni magnetic field ay ganito, ha? So bababa siya and it will release your radio frequency. So dito, ito absorb. Ito, radiation. And this radiation frequency or this radio wave frequency will be absorbed to your detector and will be analyzed by your NMR, which is, your detector is inside your NMR. No. Alpha to beta is mag-absorb. So ito kasing RF mo from rin ito eh. So from your NMR rin ito pala. Okay? So ito ang frequency mo, frequency na absorb nito. So if yung frequency na parehas sa iyong NMR, no, is the same, yung energy from your radiation is the same as the energy needed for it to flip, no? Sige, sulat natin. Energy RF is equal to the energy needed for beta flip. No? Ito yung tatandaan nyo. So, mag-flip siya from alpha to beta. No? So, yan. So, ito yung energy. Dito, may energy yan. So, di ba ang radiation naman, electromagnetic radiation, may energy na katumbas yun, di ba? So, once it changes, no, kapag na-reach na niya yung energy needed for it to flip, mag-flip na yung alpha mo to beta spin. And then that is absorbed by your nucleus. Pero once na tinanggal mo yung energy na yon, syempre, magre-reject. Wala. Magde-desorb siya. Mawawala yung energy niya doon. So from beta, it will be transferred to alpha state. Hence, the release of your energy. No? The release of your energy, which is detected by your NMR. Hence, the concept of or principle of NMR spectroscopy. So, naintindihan po ba kung bakit tinawag na NMR spectroscopy? Clear? Hindi ka target audience. Clear ba? Clear? So your nucleus no resonates with the magnetic field. So nagfi-flip yung nucleus when it reaches the energy applied is equal to the energy na kailangan niya mag-flip. Oo. So lahat ng bagay na yun, lahat ng processes na yun, si NMR na ang bahala. Si NMR device ang bahala. Yung mga nasa online setup natin, yung mga nasa Zoom, naintindihan po ba ang concept? Can I see reacts? Before we proceed. Ayun, okay. Sino nag-like? Okay. Dali lang, no? Basta ito summarize yun lang yung kanina. You need energies, no, from your radio waves for to flip your alpha spin to beta spin. So pag nag-beta spin na siya, it has energy, and then tatanggalin mo yung energy na yon. It's either tatanggalin mo yung energy na yon from your beta spin. Siyempre magre-reject yon, and mare-record yun na NMR. Okay? So let's now go to the NMR. Sige, may nag-chat. Sir, kaya po mag-click back ulit from alpha to beta bago ma-detect. Hindi naman necessarily kailangan. So, kaya nga kanina meron tayong mga alpha or alpha or beta flipping just in case na yung energy na nilagay ni NMR equal for flipping, yun yung mare-record niya. Pero kung less than siya, hindi niya, mga alpha spin lang ang mare-record niya. So, sige. That's a good question. So, hindi naman necessarily kailangan mag-flip. But if I'm wrong, please do further research. Hindi ko siya na masyadong na-research yan. Okay, so tawag dito. Sige, sige, analyze natin siya ng malalim. So there's certain frequency kasi na nilalagay si NMR, no? So as you can see kanina, that's a good question from Francis. So there's a certain magnetic field strength, no, na kailangan mag-flip, na mag-flip pala ang alpha to beta. So for example, ito lang ang Tesla, ito lang ang strength ko and you have 2 hydrogens here. You have 2 hydrogens, let's say. So syempre, ito, it will flip to beta, pero ito hindi. Kasi kailangan niya ng 7.04. Okay? So ang magre-record mo niyan is ito and ito. Kasi hindi siya mag-flip So ito, hindi ito mare-record. Hindi ito, bakit ayaw? Oh my God. Ayan, dito mare-record. So parang ganun ang concept. So yung mga nag-flip, mga hindi. Ayan, ganun kagad siya nawawala. May nag-clip. Ayan. Okay, ayun. Ayan. So yun yung concept. So we want to see the flipping para sa signal. So kung hindi nag-flip, okay lang. At least may mare-record siya na ganun lang yung spin niya. Mamaya, we'll see the importance of spinning. Ano po bang importance ng spinning sa NMR? Diba? Ayan. So this is the typical setup of your NMR spectroscopic equipment. You have your sample here, no? And then ilalagay mo lang siya sa iyong NMR. NMR contains your magnet, your detector, and your RF transmitter. So pag nag-transmit na yan, tapos kinontrol mo yung magnet, so ilang Tesla yan, no, magnetic field strength mo, i-detect yan lahat ng NMR, ang absorption from kanina yung sinasabi natin, and the magnetic field, they will be plotted on a printer, your magnetic field strength against your intensity. So itong intensity, ito yung signal, yung absorption na na-absorb ng molecule. Ito yung typical setup, no? Ini-screenshot ko lang sa net. So siyempre, hindi naman tayo mag-dig deeper dyan. Hindi yan yung kailangan sa exam. Ayan. So ito yung generator, meron ka electromagnet, sample tube, and then the detector. Once this run, no, this system runs, i-detect lang yan and it will produce your display. Ayan. So, ito yung another simple schematic when it comes to NMR. So, you dissolve it in a buffer and then, syempre, transfer mo na sa spectrometer. Set up the parameters, magnetic field strength, intensity, etc. Pero yun lang, magnetic field strength lang yung magnetic field. And then data. The solvents used are deuterated. Bakit? Can we know ano ba ang deuterated solvents?
Water. Maybe water. Yung parang
Hindi siya necessarily heavy water. So it has to do with the structure of your solvent. Actually, ayan, sa online class na sa ating mga online learners, nagsagot si Francis. Must give no signals. That's very good. Bakit? That's a good answer actually. Pero partial, yeah, no CH bonds present. Okay. Meron pa rin carbon, pero walang CH. May carbon ka pa rin, pero wala lang hydrogen. So sabi kasi niya, no carbon-hydrogen bonds present in structure. Correct, no? That's a very nice answer, no? If you analyze, kasi tinitingnan nga natin yung spectrum ng hydrogen and carbon, no? Kasi yun yung NMR. So gusto natin, walang CH bonds, correct, sige. So you can see, no? Yan yung mga deuterated. So walang hydrogen. Wala masyadong hydrogen to what? To prevent the protons from your solvents interfering with your NMR data. So tandaan nyo pag solvents, dapat walang D. Walang deuterated solvents. Ayun, wala dapat D. Don't like the D. Okay. So madali lang. Yan ang mga common. This is from Klein. 33 minutes. Okay. This is from Klein. Okay. So, knowing everything, so nag-shortcut tayo actually with the physics, with the mechanics, with the quantum realm of the nucleus. So let's now go to the main topic talaga, which is hydrogen NMR. So before we go here, may tanong ba tayo sa previous slides? So we can clarify. Yung mga nasa online setup, wag po kayo mahiya magtanong. If may tanong kayo, so we answer. Klaro naman po so far para po before we move on. Okay, sige. Klaro naman, nag-like naman. Sige. Bakit hindi ko ano yun? Hindi ko ma-navigate dito.
Andun mo sa kabila.
Ay, gano'n? Ay, wow.
Sa left side.
Ayan, okay. Yan, sorry po. So, yeah, we investigated hydrogen atoms, no? We see, ay, tama ba ito? Okay, tama. No? So, sige, we focus on hydrogen NMR. Sige, let's have a review. Bakit natin gustong gamitin si hydrogen, this is prosium, no? Sige. Let's go to the next slide. Yes, I have a slide here with the structure of your hydrogen atom. So as you can see, what are the differences of the isotopes of hydrogen? Anong differences niya? Dito. Anong differences niya? Anong mapapansin niyo dito? It has to do with the weight. Oh, correct. Number of neutrons. So it means different mass numbers. No? And as we discussed a while ago, ano yung pwedeng umikot dyan? Ang pwedeng umikot dyan ay ano gusto natin? Odd atomic number, odd mass number, or both. Diba? So lahat sila pwede actually. Pero ang ginagamit lang natin, what? Protium. Kasi natural abundance nito ay nearly 100 or 99, ganun. Basta mataas ang abundance nito compared mo sa ibang isotopes niya. So, when you use this compared with 13C in NMR, we typically use this kasi mas mataas ang natural abundance niya. And for 13C NMR naman, kasi si 13C as an isotope, around 1%, 1.0009%, ganun. Relatively mababa siya. So, typically, mas popular si hydrogen NMR compared kay 13 carbon. No? Carbon 13 carbon. Yeah. So, okay. Ayan. So, dito na tayo sa ayan. So, determining NMR spectra. So, ano ba yung mga important characteristics na kailangan natin i-take down note sa NMR spectra? Wait, may nag-chat po. Ayan yung kanila. Okay. We have to deal with the chemical shift. No? It pertains to chemical environment. No? Yan yung sinatawag nating upfield or downfield. So malalaman natin, ano po ba yung upfield, ano po ba yung downfield? Kanina sasabi ko pa yan kanina. Integration, how many atoms are there sa signal? No? Splitting or coupling, how many neighboring H atoms are there? No? So later I'll provide you, no? And the formula for that is just n+1. So kunyari, so let's say may neighboring atoms ka na isa, add ka ng isa. So 2, this is a doublet. Doublet. So later, sir, kuya, ano ba yung doublet? O mamaya, huwag tayo mong madali. We have a lot of time. 37 minutes pa naman pala tayo. Ayan. If you like to go back and or may hindi clear, magsabi ko So let's see the NMR spectrum of ethyl bromide. Anong formula ni ethyl bromide? Or ano ang different name ni ethyl bromide na lang? Kasi andito na yung formula eh. Ito na yung formula niya. Yung formula niyan ay yung formula niya. C2H5Br. Guys, andyan na nga eh. Susulat na lang. This is a bromoethane. Bromoethane. Okay? So as you can see, ayan ang mga parts. So these are the signals. Oh, hindi makita. Ito ang ating signal, no? This is signal 1. This is signal 2. No? And then you can see may mga parang mga peaks siya, no? So later, ano ba yung mga peaks, discuss natin yan. Integration line, no? Ito yung relative number of electrons for the signal. So later, ngayon, I just want you to see the graph itself and the parts. Later, malalaman natin paano kukunin yan. Chemical shift, ito lang yun. Yung numbers. No? So, asan yung upfield po dyan? Asan yung downfield? So, later, we'll discuss ano dyan. Okay? Sige. So, another interpretation, no? So, tatlo lang yan. 4. How many types of hydrogen? So you have to indicate how many groups of signals are there in the spectra. So, ano ba mga signals? Ito yon, yung mga peaks, no? Ito yung mga signals. Yan, signal, yan, signal, yan, signal. What type of hydrogen? So, yan yung chemical shift. So, dito natin tinitignan kung upfield or downfield. Sige nga, from the term upfield, ito downfield. Yan. Okay. How many H atoms are there in each type? So, integration or the relative area. And anong connectivity nila? So, coupling patterns. So, take a screenshot or notes para mamaya hindi kayo maligaw kung ano ba yung, kasi medyo ano tong mga terms na ito. So, later naman, we'll dig deeper. So, let's now go to the chemical shift, no? It is denoted by delta and it's in ppm. Ang unit niya po ay ppm. Pero, it's just the ratio between the shift of TMS, tetramethylsilane in hertz, and the operating frequency of the instrument in hertz. No? So, kanina, no, nandun tayo sa illustration, no, merong nakaganon, RF dito. So, from your alpha state, mapupunta siya sa beta state. Kanina, di ba? This is your alpha, this is your beta. So, ito yung sinasabing operating frequency, yung nanggagaling dun sa mismong NMR natin. Okay? So, pero, no, it's a relative ratio. So, this is unitless. Actually, this is unitless. Bakit? Sige nga, bakit siya unitless? Ano yung, and bakit sinasabi ko ano yung ppm? Sige, from this lang, bakit siya unitless? Anong nangyayari? Based from this, bakit siya unitless? Correct. Correct. Corrected. Challenge yan. Nakakancel kasi yung hertz dyan. That's why unitless. Ang ppm lang kasi is just, ang ppm is the fraction. Ayan, fraction kasi siya of the instrument. Basta yun na, pag sinabing ppm, it's just a fraction. Pero it's the, kasi meron tayong tinatawag sa analytical chemistry na parts per million, di ba? Meron yun na x over something value. That's a value. Pero yung sinasabi nating ppm dito, it's just the shift. No? So balik tayo dun sa kanina. Ito, ppm. It's just shift. Yung shift niya lang. Ito, shift. ppm. Okay? So, ano pong relevance na itong chemical shift? Oh, before we go there, can we use TMS as solvent? Yes or no? Pwede ba? Pwede ba natin siyang gamitin? Kunyari, gusto ko siyang gamitin for NMR as solvent. Can we use it? Oh, no. Bakit no? Correct. Correct. May hydrogen. O, di ba? Sabi natin, we don't want hydrogen sa ating solvents. So, ganun yung mga exam. Bakit? Bakit laging tatanungin, bakit po bawal, bakit hindi? So, TMS actually is used as a reference. It's a good reference because ang ganda ng kanyang signal and it's in 0 ppm. So, yun yung baseline natin. Okay? So, I forgot to discuss pala kanina. Let's just go back here. Ang layo kasi. So, the shift also depends on your solvent. No? So, yung mga typical solvent natin, ito, chloroform B, sila yung mga normally ginagamit. So, yung mga nakikita natin sa textbooks, I think ito ata, chloroform B. Pero sometimes you have to ask, no, saan galing yung data? Ano yung solvent? So, kung chloroform D, mayroon siyang certain shift if chloroform B ang ginagamit. Okay? So, let's go back. Okay. Baka may nakalimutan lang ako yun. Okay. So, syempre, okay, yun ang PMS. So your nucleus can be shifted upfield or downfield. So anong difference ng upfield and downfield? So yan na po ang sinasabi ko kanina. So si upfield, ang protons mo ay shielded, while downfield, deshielded protons. How does that happen? Ayan. So that is shielding effects. Okay. So from the term shielding, anong nagpo-protect sa proton? Ano nagpo-protect sa proton? Pag may sinabag nating shielding effect. Andyan na, oh. Oh, correct, electron. So this, no, this is your axis. Axis natin yan. So this is your rotation. So electron rotates on your nucleus, syempre, alangang sa iba. So let's say in this axis, for example, dito natin sila nakita. So syempre, as this rotates, no, on this axis, there's an induced magnetic field pa rin. So from north to south. Bakit parang mali ito? From south to north ba to? Hindi. Clear muna natin. Ayan. So ito yung induced magnetic field niya, south to north. Okay? This is the electron cloud, no, of your electron. So, syempre, electron cloud model na tayo, 3D space, ito na dapat ang ating maintindihan, no? What is the difference between low and high electron density? Saan, andito na kasi, no? Pinakita ko na. Saan na may greater deshielding effect? I mean, shielding effect. Based sa term na shield. Sinong mas maraming shield dyan? Is it B or A? Or parehas lang sila? May nagsagot sa ating chat. Let's see. Oh, correct. B. Bakit? O, yun na nga. High electron density, meaning, mas maproprotect. Ay, sorry, nabura. Ayan, ando natin. Oo, yun. So, mas, maano siya, no? Maproprotect siya from your magnetic field. That's why the term shielding. So, for example, no? Let's say, ito, gamitin natin ito. So, I'll clear the annotations. So, this is your magnetic field, no? Since low electron density siya, hindi niya ma-shield properly yung nucleus. So, ganun siya, no? Pwede siyang pumasok dyan. Pwedeng ganun. Pero pag high electron density, so, pwede siyang mag-negate na ganun. Pwede siyang ganun. Or, basta, mahirap niyang tatamaan yung, no? If we trace the sphere, mahirap siyang, so, magka-curve siya from the trajectory, no? So, this is what? Upfield. This is low field, no? Low field. Okay? So, when we say upfield, no, it is shielded. When low field, deshielded. Okay? So, yun lang naman yung important dyan. Ay, sorry. Ayan, yun ang important dyan, no? Ayan. So, pag upfield dyan, ibig sabihin, maraming electrons there, no? Dun sa nucleus mo. So, hindi makakapasok yung magnetic field doon. Yung mahirap, no? So, what's the phenomenon rather, that happens when you have shielding? Starts with letter... Shit, I forgot it. Sorry. Ano kalimutan ko? Anong phenomena pag shielding? That's the term, sorry, mental block. Ayun. It starts with letter D. It has to do with the property of a magnet. Bakit nagkakaroon pag shielding? Ganun yung property niya. Letter D. Tapos I. Okay. Diamagnetism. Ayan, no? So, ano bang difference ng para and diamagnetism? Ano po bang difference ng kuya? Sige, ito. Review rin. Ayan ang difference. So, ang difference na naman with orbitals, no? In chemistry. So, dito, meron ka pang lone orbitals. Ay, may orbitals ka na unpaired ang electrons. So, they attract the magnetic field. No? Kaya mas hindi siya pwede siyang pwede siyang pumasok along the magnetic field, yung sa along the nucleus. Pero pag diamagnetic, no, it repels the magnetic field. So this is an illustration how it repels. So you have your magnet, no? And if it's shielded, no? Ayan yung shield niya. So magre-reflect. Gaganon siya. No? So pwede naman to, that's the axis, pwede naman siyang gumanon, pero in this case, no, you have an area of shielding. Ano? Kasi diamagnetic siya eh. If paramagnetic siya, let's say, pwede siya ng ganito. Kasi attraction eh. Pwede siyang ganon. Okay? Kung may physics major dito, be ako physics major. Basta you get the point. Ang mahalaga lang naman dito is we know that this is diamagnetism. Ang nangyayari dito. No? So, pag upfield, high energy or low energy? Upfield, Upfield? Ito siya. Ito na yun, no? Low energy. Pag stronger, this is downfield. Yes. Yes. More alpha ang kanyang characteristic. Pero pag downfield, medyo beta na. Okay? So balik tayo dun sa chemical shift. So naintindihan na to na at 0 ppm, this is at lower energy. Pero dito, higher energy. Okay? So this is a field shielded. This is downfield to shielded. Okay? Okay. So aside sa nature niya, kung diamagnetic siya, chemical shift and inductive effects can happen. So what can you what's in the uppermost figure? It's an electron cloud model of what? A metal halogen, halomethyl. You have a methyl group here, and then you have your X. X is equals to fluorine, chlorine, bromine, or iodine. As you can see no dito, it pulls the electrons to one side. So this red, no, it pulls the electrons. This is your induction. So if this is your structure, so makikita nyo po. If this is your structure, no, your electron structure, so most ng electrons mo ay napupunta kay X. So yun ang naman meaning ng induction. So as you can see here, no, what's the trend? How does induction affect chemical shift? Sige nga. So, ngayon ko lang nakita yung mga chat. Wait. Sige nga, how does induction affect chemical shift?
Higher amount.
Electronegativity. Correct. So yeah, it also increases in energy, no? Pero what the thing is, when you have induction effects, no, what happens is what? Tumataas ang kanyang shift, no, from 1 to 4.3 because you're adding a electronegative atom. So you have to be familiarized with your electronegativities. Okay? Sige nga, kayo naman magsagot. What can we generalize based on the figure on the right? Ano nangyayari? Na nagdagdag ako ng chlorine, naging 3.1. Nagdagdag ako ng other chlorine, 5.3 na. O nagdagdag ako ng 3 chlorine, 7.3 na. Ano nangyari? What can we generalize? Sige, mag-focus lang tayo dito on the addition of chlorine to a methyl, to a methane. This is methane, right? Methane yan. Okay.
Or negative is naka-upload siya.
Basta you increase the number of electronegative atoms in a certain molecule, may i-increase ang chemical shift niya, magiging downward. Lalaki ang ppm. Okay? So, siguro, no, itong answer ng less hydrogen, increase chemical shift, not necessarily true. Kasi, kung wala ka ng hydrogen in the future, wala ka nang madetect sa NMR. So medyo, ang maganda dyan is yung increased halogen, it also increases the energy of the system. Hence, it becomes what? In the terms of NMR, downfield or upfield? When you increase downfield. Downfield. Okay. So, nasa context po tayo ng NMR. So, doon po natin i-relate. Yan, downfield. Okay. Very good, Jane. Okay. Okay, so as you can see, this is from Klein as well. So it's a table, no, of the effect of adding oxygen to an alcohol, to an ester, or the effect rather of oxygen to an alcohol, ester, and the effect of carbonyl group. And as you can see here, no, meron kasi tayong mga certain values talaga for ppm per group, no? So let's go to those values. So ito yung mga values natin, no, for the R groups. So ano ba yung R groups? So let's say, di ba kanina meron tayong ganito? So this is methane, no? And then we replace this with, let's say, Cl. With Cl, ayan. So this is your R group. Sa R group or side group. Ayan, so ito yun, methyl. So a certain R group or a certain group has a certain chemical shift. So methyl itself has a shift of around 0.9. Pero when you add what? Diba? When we add the halogen, let's say ClCH3, anong nangyayari? When we added Cl here, from 1, nagiging 3.1. Ano nangyari? Shielding o deshielding? Correct. It's deshielded. So dito, no, try muna natin, no. So balik tayo dito. If we 57 minutes. If we put Cl here, ang mangyayari, kukunin niya yung electron cloud, no? Ang electrons medyo mapupunta kay Cl. So mangyayari, mawawalan ng shielding effect dito kay Cl3. That's why, di ba, ito red, more electron something, no? Intense yung electrons siya dito. So dito, mababa yung mababa yung shielding effects mo kasi nawawala yung electrons mo dito, napupull, hinahatak ni Cl. Understood? So kung hinahatak ni Cl, which is, ulitin lang natin, sino ang downfield? Sino ang upfield? A o B? B. O siyempre, downfield ito, mas downfield ito. Ito, upfield na yan. No? So wag kayong malilito sa ating chemical spectra, sa shift natin, sa spectrum. Okay? Sana ba tayo nawala? Ayan yung value. So let's go here, no? So as you can see, oxygen, and carbonyl group, nakikita niyo yung epekto nila, nag-i-increase or decrease. So is this reasonable? Bakit? Bakit mas mababa ito compared dito? Nandiyan na rin sa table yung explanation. Okay, correct B for kanina answer. This is reasonable kasi what? Tingnan nyo, dalawang oxygen to. Compared dito, isa lang, carbonyl lang. Dito, ester. You have two oxygens that can pull the electrons from your hydrogens. Okay? Hence, mas mataas. So, dito lang, effect of alpha protons. So, ito na, di ba? Effect of alpha protons. Ayan, basta ito. Ito. 2.5, 3, and 1. So, carbonyl, magsishift lang siya by 1. So, oxygen by 3. Okay? So, syempre, gusto natin mapadali ulit ang buhay natin. May mga certain values naman. Hindi tayo magka-calculate. So, usually, no, dito kasi kina-calculate yan. Ito, kina-calculate yan. Pero pag binigyan tayo ng graph, hindi naman tayo magka-calculate. We are after the location in the graph. So, as you can see here, no, dito, it says here, no, increase in magnetic field strength, increase shielding by extra nuclear electrons. So, as you can see, this is a graph, no? So, this is at 0 ppm. This is around, let's say, kasi ito, pag aromatic, kasi 7 ppm na. Ito, aromatic. And then dito, so around mga 12. So, is this reasonable? Kuya, sabi mo kanina, mataas ang value ni ppm kapag mayroong electronegative. Bakit ngayon na aromatic lang siya, pero ang taas niya, 7 ppm? Bakit itong mga alkyl groups lang, mga around 1 lang, 1 to 2, or 2 to 3? Bakit ito 7 ppm? Wala ka namang Cl dyan, wala ka namang halogen dyan. Sige, may nagsagot. Yes, it has to do with the resonance structure, pero rather resonance is the anisotropic effect, no? What does that mean? Sana meron ako sa next slide. Ay, wala. So, anisotropic effect, ganito lang siya. So, syempre, you have your ring, di ba? So, sorry. So, these rings produce, meron ka mga pi bonds dyan. So, umiikot siya up and down. So, ang na-induce mo na magnetic field, ganito lang. So, parang magnet pa rin siya. Diba? That is anisotropic effect. So, your ring, kasi merong pi electron delocalization. What do we mean by delocalization? Ayun, correct. Your electrons move to your benzene ring. So usually lang naman may delocalization yung mga pi bonds. So kaya that's why you should have a better understanding of basic ORGCHEM talaga bago NMR. Okay, 1 hour. Ayan. So knowing all this, we can now go to answering or predicting the chemical shifts of the signals. Okay? So, sige, ito yung mga argo. Ito, balik tayo kay bromoethane. Can you list in increasing ppm the given protons of the ethyl bromide A, B, C, D? Sige nga. I'll give you 30 seconds. So, ang sagot dyan parang ganito. Pwedeng ganyan, pwedeng ganyan, or pwedeng ganun. So, dapat ganyan makita kong sagot. O nga pala, if we do not finish the lecture today, meron pa namang next part which is on September 21, same time. Kasi 30 minutes na lang, guys. 26. Okay. May sagot na? Anong clue dyan? Nandito si BR. Anong in increasing ppm? Sino ang may least ppm? So, dapat siya yung nasa left. Uh-huh. Equal to B. Okay. So, may mga nagsagot na. Let's see if okay ang sagot nyo. So, as you can see, no? Let's see. So, unahin natin. Si A, siya ang pinakamalayo. So, siya ang pinaka-dulo. Pero, since nasa same carbon sila, pwedeng A greater than B, B or C. Pwedeng C, pwede yan. Pwede rin to. Basta interchangeable silang tatlo. Pero for the sake of this, no, ito lang ang ating preserve. And then, syempre, ang character nitong dalawang H na to, iba na dito kasi it's on a different carbon. Itong carbon na to, malapit kay bromine. So, anong nangyayari dito? These are more deshielded. Diba? Deshielded. Natatanggal yung electron sa kanila. Kaya, pwede itong A equal to B equal to C, then greater than D is greater than equal to E, or D equal to E. Actually, ito ang sagot. Bakit? Kasi nga, di ba, equal lang sila. Same carbon lang sila, itong dalawa. Itong tatlo, same carbon lang yan. Carbon 1, carbon 2. That's why the answer is this. Pero if you answer this, no, tama rin ito. Kasi less than or equal naman. Tama ba to? Kasi tama ba to? Tama ba to? Is this the same with this? Tama ba? Math 10. If B is equal to A and B is equal to C, therefore, A equals to C. So, tama. Okay lang. O, let's see kung tama tayo. O, tama. Tama tayo, guys. So, yan. Papakita ko sa inyo. Bakit? These are the 3 hydrogen dito. O, mas malapit sila, di ba? Kasi dito, di ba, sabi natin, shielded part ito. O, shielded ito. Di ba? Mas malapit siya sa 0 ppm. Ito yung integration 3. Ito 2. These two are nearer your bromine, hence they are more deshielded. Kaya ito yon. Ito sila, and ito sila. So, naintindihan yung shift? Naintindihan kung bakit yan ang sagot? Okay? O, sige. Yung numbers ito, integration value to eh. Later we'll discuss ano yung integration value. Okay? So, ang sagot ni Jay, increasing tayo ha, hindi tayo decreasing ppm. Ang increasing ppm natin pa left. So, do not be confused with that. So, from right to left is the increasing delta or ppm. Okay? Sige, clear natin. Clear. Okay. Teka lang. Oh, yan. Another. Sige nga. Ito, medyo ganun naman. Is in increasing ppm the given protons of the compound. So, pwede siyang 1 minute. Na timer ako. Okay? Okay. So itong F, ano yung F? Bakit may F dito? That is may hydrogen pa dyan. That's yung F. May hydrogen atom ka pa. O, ayan. Time's up. Sige nga. May sagot na ba kayo? Nasagot na? Nasagutan? Hindi. Nagutan? O, sige. Check natin. What is the first thing you need to do? You have to group yung mga same what do you mean that? Mga same ang kanilang signal. So let's group first itong A. So ito same sila ng signal, di ba? Itong si F, same ba with A and B? Hindi, kasi hydrogen yan. Hydrogen lang yan. So, sige, iano natin. Kapag nag-iba tayo ng marker, may hydrogen group ka pa dyan na isa. So, we will have what? How many signals? 1, 2. Ito, dalawa hydrogens mo dito. Pero, ano yan? Isang signal lang yan. Diba? Ito, anong meron dito? CH3. Diba? CH3 yan. We have 6 hydrogens, pero 1 signal. Kasi pare-pares lang sila ng nature, diba? Ito, 1 hydrogen, 1 signal. O ito, 2 hydrogens and ilang signal? 1. Okay. 1 signal. Same goes with here. 2 hydrogens pero 1 signal. O dito, how many hydrogens? Sa E. 3 hydrogens. Kasi ito ay what? Meron kang CH3 dyan. Pero, ilan ang signal niyan? Isa lang. O, sige nga, i-rank natin sinong pinaka-upfield. Sino pinakamalapit sa oxygen? Or sino pinakamalayo? Upfield eh. Ang pinakamalayo ay sila A. A, B. So, A equal B. Okay? Ano next? So, ito ay electronegative atom, ha? Electronegative. Oh, which is next? Sinong next na malayo sa mga electronegative oxygen? Sa mga oxygen? Okay. Letter F. Bakit F? Ito kasi ito yung carbon mo, no? Ito malayong malayo kasi dalawang carbon before O, right? Carbon 1, carbon 2, carbon 3. Ay, carbon 3, tas O. But in the case of this hydrogen, no? Hydrogen, carb, tapos ito yung carbon niya, tas ito na ulit, ito na yung carbon niya. So dalawa lang before your oxygen, no? That's why letter F ito. Oh, what's next? Ano yung next? It's letter what? Letter nung next. Letter C. Bakit? Ito, malapit lang siya eh. 1. 1. Ito, 1, 2. So, may nagsagot kasi letter E. Bakit hindi si letter E? Guys, look. Si E, isa lang yung oxygen niya. Pero ito si C, dalawa yung oxygen niya sa gilid. So, pwedeng induction effect, ganun, no? Compared dito, isa lang, which is yan. So, C is less than E. Ay, sorry. Tama ba? F is greater than C. A, B, F, C. Okay. Ayan, no, tama. Okay, C. What's next? Susunod na si letter E. Ayan. Okay. Bakit letter E? Saan na yung one carbon tas oxygen. Okay? And then, lastly, letter D. Siya yung pinaka-deshielded. Bakit? Ano naman ito eh. Ito malapit kasi mas electronegative na to malapit dito. And then ito ay pinupul rin siya ng carbonyl group. Itong group na to. So let's see kung tama ba tayo. Ayan. So, ayan yung aking solution. Wait lang, clear natin. So that's the at yan, medyo tama naman. Pero yung actual no, A is equal to B kasi same group naman sila, which is, and then mas malaki si F doon ng onte. So bakit why does this make sense? Kasi nasa same quadrant sila. 'Di ba? F is equal to C pala. Bakit F is equal to C? This is an actual no, pero kanina sabi natin less than. Bakit F is equal to C? Kasi look at the approximation of their carbon. Kaya lang naman naging greater than si C natin kanina. We considered this. No? Pero as you can see, F is equal to C kasi pares lang naman silang pinupul na ganun. Okay? And then you have your letter E dito. Kahit malayo siya, no? Pero mas malapit siya kay oxygen. Okay? Compared dito, dalawang carbon pa kasi yan. Dito, isang carbon lang, tapos oxygen na agad. Dito, 1, 2, 3. Dito, 1, tapos oxygen na agad. That's why E. And letter D, there are two opposing electronegative atoms, no? You have 1 and 2. So si letter D, para siyang napupul ni oxygen from your carbonyl, no? Carbonyl group. And then, napupul rin siya ng oxygen mo. Dito. Kaya si D ang pinaka-deshielded kasi dalawa. So we know naman, di ba, kapag molecule, ang electron cloud usually ganun, pahaba, depende. So yun yung i-visualize ninyo. So you have to see the proximity kapag tinitingnan yung chemical shift. 10 minutes. Ayan. So this is the answer key from Klein. So as you can see, no, sige, discuss natin. There are actual values actually. So hindi na tayo magdidig deeper doon with the actual values. Ayan, no. You can see 2.7 to, actual niya 2.6. This is 1.1 kasi sobrang layo na niya eh. Ang layo na niya dun sa mga electronegative. Kaya 1.1 siya. Ito, 3.4, no? This is 3.4 kasi malapit siya sa oxygen. Ito naman, 3.9, siya ang pinaka-deshielded. May oxygen ka dito, may oxygen ka pa dito. Okay? Dito, 2.7 kasi it is alpha to the carbonyl, meaning sabihin ng alpha, isang carbon lang, ay dalawang carbon, 1, 2, and beta pa siya sa isang oxygen, 1, 1, 2, 3. Yun yung sinasabi niya, kaya 2.7 siya. Okay? Ay, nawala. Ayan, okay. Ito, 2.7, alpha to the carbonyl. So, do you know naman alpha-beta configuration? Alpha, beta, carbon. So, ano lang yan, yung alpha-beta na sinatawag dyan, arrangement lang ng carbon, carbon molecules. Pag alpha, siya yung chiral center, usually. Pero in this case ba, is our molecule chiral? May chiral center bang molecule? Wala. Wala siyang chiral center. Okay. So, naintindihan po ba si chemical shift? So, medyo alam ko, medyo ano pa sa'yo to, kaya Pero at least na-identify mo yung difference. Okay. Kaya kapag dinescribe ko sinong most upfield, A o B. Sige. Sinong mas upfield sa kanila? A o B. By proximity. Ang upfield ay C. Correct. Very good. Okay. Kasi siya ang pinakamalayo sa oxygen. Ito, lapit lang. Very good. Sige, clear. Sige. So I think yung mga sample problems i-discuss natin next meeting kasi 10 minutes na. So let's now go to the integration. Ito madali lang to. When you say integration, it's the height representing the area under the signal. So yung NMR mo naman may lalabas siya na integral values na 2.7. Ayan, andito na sa baba. So ito lang naman yung integral line. Yan lang yung sinasabi niya. So ano importance ng integration? So yung integral values, it shows you the number of hydrogens for that for the signal. So this is just how you get the integration values, no? So as you can see, you just have to divide all the integration values to the lowest integral, which is 2.7, to get the ratio. Kasi ang integration ay ratio between hydrogen atoms in a molecule that are dependent on your signal. O sige. Since ito ang ratios na bigay na, no? Yan ang ratio. So these are your integration values. Yan ang ratios mo. Your final ratio would be, bakit 2:3 is to 2:3? Anong ginawa natin? We just multiply this by 2. By 2. By 2. By 2. Ito ay given. Given yan. So, your integration values are always given. So, itong 2:3 to 2:3, makikita nyo, sa taas nito ay may 2 hydrogens, 3 hydrogens, 2 hydrogens, 3 hydrogens. That's the integral value. So, ibig sabihin yan, there are 2 hydrogens pertaining to this signal, while this signal pertains to 3 hydrogens. Okay? Yun lang naman pag integration. So, madali siya, di ba? Okay? Ayan. So, minsan, we have to know the molecular formula and symmetry. So, ito ratio niya is 1:3, di ba? Pero we know the formula is C5H12. Pero when you see the spectrum, this is for what? 9 hydrogen, and this is for what? 3 hydrogens. Saan itong 3 hydrogens na ito? Dito. How about itong 9? Sige nga, dito siya. Bakit ganito? Bakit ito ang 9 hydrogen? Bakit medyo upfield siya? Aside sa O, anong napapansin nyo? Sino ang mas malayo? Is it this one, 9H or 3H? Correct. Correct. 1 carbon away from oxygen. So ito, no? Ang signal niya ito. Kasi it's a 1 carbon away from oxygen. Unlike this, no? Oxygen na agad. Okay? So you have to know the molecular formula. Kahit ang ratio mo 1:3, pero it corresponds to 3 hydrogens for one and 9 hydrogens for the other. Pero syempre, ano ba ang 3:9? 1:3. Okay? You have to also consider, ayan yung result. Okay? You have to consider the symmetry. The symmetry. So, ang ratio niya 2:3. Pero ito, pwede itong signal 1, signal 2, signal 3, signal 4. Bakit ang ratio niya 2:3? Tapos dalawa lang ito. This is 2 hydrogen. And ilang hydrogens dito? Based dito sa ratio. If this is 2, this is 3. Okay? O bakit? O bakit ito 2 to 3 lang? Bakit dalawa lang yung signal? 4 equals to 3. Correct. For sabi isang classmate nyo, ganito. Bakit? It has to do with symmetry. Symmetry. No? So, syempre, symmetrical yan. Hatiin mo dito. Ito equal to dito. Ito equal to dito. Hence, this is A. And this is B. O, bakit si B ay nandito? Sige nga, na common sense. Kanina pa tayo dyan. Malayo siya? Oh, electronegative. Oh, may natututunan. O, sige. Baka mag-extend na tayo 10 minutes or 15. Kasi sample problems na lang is for next. Yung mga sample problems kasi natin integrated na eh. So, lahat ng inaral natin. Okay? So, ito may problem tayo. A compound with molecular formula C5H10O2 has the following NMR spectrum. Given the integration values, find the ratio of H atoms. O, madali lang yan. Simple ma. I'll give you 30 seconds. Siyempre, mag-calculate naman kayo. Alam nga, i-mental math nyo pa. Sige. Pero no, kahit walang calculate, you will see from the shape, no? Kung alin yung may pinakamarami. Ayan. Sige, may nagsagot. Okay, ang galing naman na itong ating online learner. Effective ba online class? Baka pag ako yung prof. Joke! Depende. Oops. Huwag daw nga i-compare ang online class sa face-to-face. Anyways. Sige, may sagot na ba? May nakatama na. Actually, ang bilis. Ang step lang naman dyan, you divide all the integration values with the lowest. 6.33 divide 6.33 equals to gano'n. Then, divide by 6.33 ulit. 19.4 equals to gano'n. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2. Okay. So hopefully, kung di nyo nasagutan, ito ang sagot. Madali lang. I-discuss natin. 1 into 6. Ayan, divide mo lang. And then, syempre, nearest integer, this is 3, this is 6. That's why the ratio is 1 to 3 to 6. Ito na ba ang molecular formula? Ito na ba ang molecular formula niya? Or empirical pa lang to? It's empirical at the same time molecular. So kung ano yung present sa inyo at hindi nyo na siya ma-multiply by 2 or 3 or hindi nyo na siya ma-divide by 2 or 3, that's the molecular formula already. So we're lucky to see that the compound, which is C5H10O2, is the empirical and molecular formula. So kaya mahalaga yung mga proton natin, mga integration values. Okay? So last, may naintindihan po ba ang integration? Madali naman, no? So when we write, no, the integration, saan ang 1 hydrogen natin? Saan natin nalagay yung 1 hydrogen? Sige, A, B, or C. Saan ito? This is for A, correct. Ito. For C. This is for B. Okay? So, pag isusulat natin siya, 1, that pertains to 1 hydrogen, this is 3, and this is 6. Kasi may mga NMR spectrum na wala nang nakalagay na H. Pag nakita nyo number 3 sa taas, that's the integration number. So, balikan natin yung ethyl, no? Ito. Oh my God. Ano yan? So, kanina, pinakita ko to sa inyo. As you can see, no, may integration line, 2. So, pag nagsulat kayo dyan, this is 2 hydrogen, this is 3. Okay? So, ganun. Okay. Last. So, sometimes, no, may makita kayo, kuya, ano ba yung mga signal na yan? Bakit may mga splitting? So, minsan, no, the effect of one hydrogen can have an hydrogen or an atom can have an effect on the neighboring atom. Diba? That's what we call multiplicity. So how does that happen? So syempre kung si hydrogen, ito yung signal mo, no? Wala nang hydrogen dito, single lang siya. That's what happens. Pero for example, you have this molecule, no? And meron kang hydrogen dyan. So si hydrogen, pwede siyang mangyari is may hydrogen dito, ang mangyayari, mag-i-split yung signal. No? And the signal would be a doublet. Ito yun. So there's a splitting, no? In the peaks. Oh, this is a better illustration. Let's have this and this. Oh, so let's have the effect of B on A, on the signal. So based dito, no, si B can have two spins. It's either against the field or with the field. That's why doublet. Okay? So pinapakita lang naman, si HA, ang signal niya, pwede siyang HB plus N1/2, pwedeng HB, ito yung pala yung plus sa baba. And then, this is the -1. O, ayun. So, nai-split siya, no? Ganun yung, pero may yung HB dyan, ito. This is just a visual representation, no? Pero hindi ganito yung nangyayari talaga. So, ang nangyayari lang naman, ang tatandaan nyo in this case, dahil tutorial to, kapag meron kang katabing hydrogen, ito, no? Ang nangyayari, it's either against or with the field, kaya doublet siya. Okay? So, ano bang, di ba kanina may sinabi tayo, kuya, ano ba yung N+1? So, later discuss natin yan. So, in this case, no, this is your hydrogen, may katabi siyang another hydrogen. So, meaning, ang multiplicity mo ay 1 neighboring hydrogen plus 1 equals 2. 2 is doublet. Hence, ganito ang magiging signal. So, this multiplicity is a pattern-wise. A pattern siya. So, paano kapag meron ka pang neighboring atom dito? HB, let's say another. Ano mangyayari? Oh, ito pala. Ito yung sinasabi ko, no, na splitting, no? Pwede siyang against the field, ay within the field or against the field. Kaya nagiging doublet. This is your HA, and HB is different from HA. Okay? Iba ang nature. What if ito nga? Paano kung tatlo na? Oh. Tatlo na yung atom mo eh. Tatlo na. Ano mangyayari kung tatlo na? What happens is, meron kang protons na parehas na same field. Pwede na dalawa na magkaiba. And then pwede na parehas sila. Ito yun, no? Ito. So, ito lang pinapakita lang natin, no? Magiging siyang triplet, no? So, if we apply M+1, ito lang yung laging tatandaan nyo. You have your HB, no? What is the effect of HA with B? So, you have HB. Ilan ng HA mo? Dalawa. These are your neighbors, no? Sabi natin, n is equals to neighbors. So, n+1, 2 + 1 equals to 3. Ito ay triplet. Hence, the signal, ito. Naintindihan? So, ito rin yun. So, yun yung makikita nyo sa NMR. Ayan. So, sige, mamaya, discuss natin. So, constant yan, no? Yung coupling kasi tinatawag. Tawag dyan sa splitting ay coupling. And it has a coupling constant called J. So, hindi na natin kailangan i-measure yan kasi hindi ang important lang naman for NMR spectra or spectrum is yung shape. If it's triplet or quartet. O, bakit ito quartet? Bakit quartet to? Apat yung signal. Pero, constant ang kanilang coupling constant. Kaya quartet yan. Kunyari, meron kang NMR, Ito signal na to, ang layo niya dito. Is this doublet? Is this a doublet? Hindi. Pero ito, doublet yan. How about this? Doublet? Ano lang difference? When it comes to integration. Intensity kasi ito eh. Intensity or integration. Pares silang doublet, but this is a much intense or less intense? More intense signal. Sinong mas maraming hydrogen dito? Is it A o B? Ang mas maraming hydrogen, eto, si B. Kasi, high ang intensity niya. Okay? May nagtanong, paano po malalaman kung ano yung HA and HB? So, ano lang naman yan, no? HA and HB is just the nature of your hydrogen. Para lang siyang, subscript. So, just to say, the blue ones has the same nature, and the red ones has the same nature as well. So, HAs are equal, HBs are equal. Ganun lang siya. Okay? Ayan. So, ito ay, lang ito, splitting of splits. So, pwede kasi, this is more complex, pero for the sake, next time na lang ito. You can have quartet of triplets, triplet of triplets, etc. Depending, usually ito sa mga aromatics. Pero we're just focusing on the aliphatic, meaning, yung mga horizontal lang. Okay? So, medyo, sige. Para madali, ay, bakit wala? Ayan. So, ito yun, no? Multiplicity of your neighboring protons. So, ang technique lang dyan is n plus 1, no? Kung si hydrogen may katabi pa siyang isa, doublet. Pero pag marami siyang katabi, it's triplet. So, magiging intensity mo, doublet, ganyan. Triplet, ganon. Quartet, 1, 2, 3, 4. So, ganyan, ito yung signals, no? Pag sinabi mong doublet, quartet, quintet, 1:4, 6, 4, 1. Ganun lang yan. So, ito, no, in relative intensities of individual peaks. Sige, medyo nakakalito to eh. Balik tayo. Sige nga, given tayo dito sa mga ito, which of the following carbons can produce a sextet? Ay, hindi wala yun. Sige, bigyan ko muna kayo ng sample problem. So, let's go with this, no? Ito. Investigate natin sila individually. So, kapag sinulat natin yan, ganyan yan, skeletal, no? H, you have H, and N2. Let's go with A. So, ito, same nature sila, no? Di ba? So, one signal lang yun. One signal ito. This is one signal. This is also another one signal. Okay? So, we're expecting how many signals? 3. Okay? So, ilan ang neighboring atoms nito? Ilan? Okay. Ayun ang pala yung sagot. Ilan neighboring atoms niya? We have what? 1, 2. Ilan? Teka lang. Parang mali yung figure ko. Wait lang ah. Ano yan? It has what? 2. Ito lang naman neighboring eh. Pag sinabi nating neighboring, yung katabi niya lang. So, it has 2. So, n plus 1, 2 plus 1 equals 3. So, ano ito? It's a triplet. So, ang signal mo this time is like this. Right? How about letter B? Ang dami niyang katabi, di ba? Ilan ang katabi niya? 1, 2, 3, 4, 5. 5 lang ba? Bakit 6? Yung kasama niya pa. Sure kayo? Sure ka? Sabi natin, isang signal lang to. When we say isang signal, parehas lang, when we say isang signal, intense lang siya. So, parehas lang sila ng property eh. So, ang papakialaman mo lang nasa gilid. So, you have 5 neighbors, di ba? Plus 1 equals to 6. So, have we answered kung ano ang sextet natin? Letter B. Okay? O, letter C. Ano ang nature nito? How many neighboring atoms do we have here? 2. So, n plus 1 equals to 2. Equals to 3. Kasi 2 plus 1 equals to 3. So, this is also a triplet. So, sextet, 1, 2, 3, 4, 5, 6. O, basta 6 yun na. 1, 2, 3. So, when we go to the next slide, consistent ba tayo? Ito ay sextet for B. For consistent. Okay? O, letter A is a triplet. Di ba? Triplet naman. 1, 2, 3. Okay? Triplet siya, no? And this letter C rin ay triplet. 1, 2, 3. O, sige, review. Bakit si letter C ay nasa ditong shift? Very good. Kasi malapit siya sa NO2. Downfield. Correct. Downfield. This is downfield. Downfield kasi malapit siya sa electronegative. Kinukuha niya yan. Okay? Okay. So, given all of these, eto just, ano lang, hindi mo na pwedeng makita yung multiplicity kapag more than 2 carbons na. Ito, wala nang splitting na magaganap dyan. Kasi ang layo na nito. Compared mo dito, tsaka ito, malapit lang sila. Okay? So dito, hindi mo na to i-count. Kaya nga, di ba kanina, hindi na natin kinount yung more than 2 carbons. So neighbor, as in neighbor, katabi mo lang. Not neighbors of neighbors. Okay? So, last, I think this is the last before we end today. Kaya nag-extend nga tayo. So I'll give you 1 minute for this. Determine the multiplicity of each signal in the expected NMR spectrum of the following compound. I'll give you 1 minute, no? And then we'll answer it together. So sa mga, hopefully you answer it within 1 minute so we can discuss. Sa mga nahihirapan, no? Ang unang gagawin dyan, you have to label all the hydrogens. No? And then group them. O, ayan. Okay, lagi nyo tatandaan na merong lone hydrogen dito. Kasi dalawa lang yung methyl mo. Okay, tapos ng 1 minute. Let's try to answer, no? So first, locate the signals na pare-parehas. So, how do I make this easier for me? So, sa inyo, para maging madali, ganito lang. Isulat nyo ng kompleto. So, CH3, ito, dalawang hydrogen to. So, since parehas naman na nature ng hydrogen na to, no, we can write na H2. Kasi parehas naman sila ng nature. No? And then ito, CH3, CH3, CH3. Ayan, meron na tayong visual. So, we just have to group everything. This is one group, kasi iba ang nature niya, no? From the others. Ito, magkaparehas sila. Ito, medyo, bakit ito magkaiba dito? Ito ay nakakabit sa electronegative, no? Compared dito, medyo malayo siya. So, different. So, hindi sila pwedeng magkaparehas. Ito, tatlo ba ay magkakaparehas ng nature? Kaparehas? Binilog ko na. Oo naman. Ayan, yes. And then sabi nga nila, distance from electronegative atom. Correct. Ayan. Sige nga, I'll group, no? This is group 1, this is group 2, 3, 4, and 5. This is carbon. Ayan, medyo nag-integrative na tayo. Carbon backbone. 1, 2, 3, 4, and 5. Sige nga, dun sa mga ilang signals ang maproproduce dito? Dapat masasagot nyo na. Hinighlight ko na. 5, right? 1, 2, 3, 4, 5. Okay? Sige. Sino ang may pinaka-intense na signal? When we mean intense, siya yung may pinaka-maraming hydrogen. Signal number? Correct. Signal number 5. Ito ang pinaka-intense. Okay? So let's now go to the multiplicity. Let's focus on hydrogen. Okay? How many neighboring atoms or hydrogens ang meron dito? How many? So ito ang medyo complicated with the analysis. Hindi pwede ang none. Bakit hindi pwede ang none? Ang sabi natin, di ba, neighboring atoms can be like this, which is germinal, and this is vicinal. This is vicinal. Germinal ba ang term? Basta ganun, germinal, same carbon, and then magkalapit na neighbor carbons. So in this case, ito, same carbon, ito, 2 carbons. Diba? So in this case, ito, no, when we count, 1, 2. So pwede pa, neighboring atoms niya to. So ilan ang neighboring atoms niya? We have, ilan? 6. Okay. O ba, 6. Correct. 6. So, if we need to go to the multiplicity of group 1, this is 6 plus 1, therefore 7. Ano siya? Septet. Okay? Ang expected graph niya ay ganito. 3, 4, 5, 6, 7. Ayan. So let's see if tama tayo. Let's go to the figure, to the answer key. Ayan. So this is your hydrogen, and it has 6 neighbors, no? 6 plus 1 equals 7, so septet. So tama tayo. O, sige nga. How about, sorry, napakita ko na pala answer. Pero sige, how about number 2? Delete na natin ito. Oh, correct. Oh, ano tayo? Isa, 1 plus 1 equals 2, which is a doublet. Okay. Correct. Oh. Aha. Ayan, doublet siya. Okay? Oh, ito yung answer key ko since medyo magto 2 hours na tayo. Ayan, so let's see, no? Ito ay what? Ay, sorry. Delete natin here. Annotations. So ito ay what? Ito na lang. Kasi it has what? How many neighbors? 1, 2, dalawa lang. Ito lang. 3. Dalawa lang actually. Kasi same signal lang naman sila, no? So dalawa lang. And it's a triplet. So based from the answer key, triplet siya. Pero intensity niya ay 2. Bakit? Kasi it accounts for 2 hydrogens. Diba? Okay. So, answering everything, ito yung sagot. No? You have to group your protons, no? Kung pare-pare sila na nature. Afterwards, no, you get the neighbors. So, focus ka muna sa isa, you get the neighbors. You have 6 here. 6 plus 1. O ito naman, you have isa lang, no? One neighbor. Dito, how many neighbors? Carbon 1, carbon 2. Dalawa lang rin. Eh dito, bakit ito singlet lang? Bakit ito singlet lang? Sige, last. Okay. Okay, tama. So, ganito yan. Bakit singlet siya? This is carbon 1, carbon 2, carbon 3. Malayo na siya. So you have to ano no, check the carbon. That is carbon 1. Diyan ka mag-start. Unlike this one, no, bakit ito na-consider niya pa na neighbor? Kasi what? This carbon is carbon 1 connected to carbon 2. Medyo nakalito, no? Pero as you can see, no, you have your carbons here connected to the carbon backbone, and the carbon backbone has another hydrogen. Okay? Kaya carbon 1, carbon 2 yan. Yung sinasabi kong 1, 2, 3, 4, 5, yan yung sa backbone. Pero if you see, no, the relative number of carbons, like for example dito, this is carbon 1. Kita niyo pa ba? This is carbon number 1, this is carbon number 2. If you are referring to this group, ha? So gets naman. Okay. Sige. Okay, meron pa ba tayo sample problems? Ayan. So, I think para hindi tayo lahat mahirapan, ito yung mga chemical shifts ng mga R groups natin. So, hindi tayo magpapakahirap para mag-calculate, no? We just have to familiarize ourselves, no? When you see this table, ibibigay naman to usually. Pero you have to familiarize yourself kapag downfield, usually mga alkyl groups. Pag mga middle siya, mga 5 to 7 alkenes. Kapag 7 onwards, it's either aromatics, aldehydes, or carboxylic acids. Sige nga, ano ang parehas sa kanila tatlo? Anong meron sa kanila? Bakit sila ay for the downfield side? Meron silang mga R group na. Ano yung nature ng R group? Electronegative, electropositive, electro-withdrawing, ano? Correct. Correct rin si Francis. Electronegative. So as you can see, no, yung mga R groups na to, electronegative yan. Pero in this case, si aromatics, it's because of what effect? Ano yung effect na diniscuss natin? Kaya siya nandito around 7. Letter A. Okay. Anisotropic. Medyo malapit na si Francis. Asinotropic. Anisotropic effect. Okay? Ayun. So, anis daw pala. Okay. Ayan. So, as you can see, no, ito, better version. Pero ayan. So, for example, no, 1.7 to 1.3, nagdagdag siya ng additional R group, tumaas. Okay? O, humaba yung chain, tumaas. Nagdagdag ka ng benzene ring, tumaas. Okay? So, that's the trend, no? As you add more length or as you add more electronegative groups, more benzene ring, ganun, mas nagiging deshielded yung ating nucleus. Okay? Kasi yun ang ano, no? Kapag maraming kinukuha sa'yo, di ba, maraming pupunta sa'yo, ano ba ang target ng mga maraming pumupunta sa'yo na kumukuha ng electrons mo? So, ibig sabihin, mas deshielded ka. For example, kumukuha ka ng energy from a certain, or sa life lang, for example, meron kang, ikaw as a person, kunyari, shielded ka with your everything. Pero pag kunyari, may mga problema na tapos hindi mo kinakaya, kinukuha nila energy mo, gano'n. Nagiging deshielded ka. Ganon. So, ganon rin with the electrons, no? Pag kinukuha nila yung electrons mo, nawawala yung shielding, yung shield mo for your nucleus, for yourself. So, that's the purpose of ano. Kaya ayaw natin ng mga negative. Gusto natin positive para nasa atin lang yung shield. Ganon. Gusto natin ganon. So, ayan. So, I think for aromatic, so siguro this is for the next meeting na lang. So yung mga mga samples na to ay more integral na. This would be discussed on September 21. So hopefully, yung mga nasa online class, they can go on-site. Kasi mas maganda talaga na i-discuss siya sa board. And then, before we end, I think, ayun lang for today. Kasi meron na tayong na-discuss na natin yung mga basics. And for next meeting, which is on September 21, we will deal kung paano lahat nangyayari yung chemical shift, integration, and complaint. Sige. So summarize na lang, no? Summarize na lang natin before we end. Let's just go. So naiintindihan nyo na itong tatlong to. Chemical shift, integration, and splitting. Naiintindihan na? So, okay. So siguro kayo yun ang basahin to kahit papaano. How about sa online class? Can you read this now based from our discussion? Sa mga nasa online participants natin. Ayun, okay. So, sige nga, last na lang. Bakit hindi natin ginagamit na solvent ito? Ba't di natin ginagamit na solvent itong si tetramethylsilane? Hydrogens, correct. O, ano tong mga numbers na 2 and 3? Relative ratio. Number of hydrogen, carbon. H. Saan ang upfield dito? Is it 0 or 6? 0. Ang downfield ay 6. So, ayun, mabilis na, no? May nakakasagot, less than 10 seconds. So, let's continue the discussion on September 21. So, hopefully, nandun pa rin kayo. So, that's all for today's tutorial. Sorry, we extended for 27 minutes and hopefully, we discussed everything naman.